Hello AFDA students, and welcome to AFDA video lesson 16. This is an introduction to functions. Hopefully what we're going to be able to do today is define relations, what a function is or isn't, something called domain and range. You may have heard about domain and range, and we want to be able to evaluate functions and possibly analyze their graphs at some point. Now, terms that we have here is something called a relation, the word function, a function rule, something called domain, range, and then the last thing we'll talk about is a vertical line test. And that will come into this graphing situation we'll look at here in a second. Let's look at example 1. It's got a table of values, and it's got some, I guess, real things in here. It talks about hours and pay. Some of you guys might be familiar with that if you're working. But it says if you have 0 hours, you get 0 pay. If you work 1 hour, you get $6 of pay. If you work 2 hours, you get $12. And if you work 3 hours, you get $18. Now, some of y'all can probably describe what's happening there or the rate of pay per hour. But if you remember back when we had tables of values before we were doing some graphing, we would organize those as ordered pairs. So let's look at this table of value. You could order this as 0, 0, 1, 6, if you will. You could organize this as 2, 12, and 3, 18. Now notice this has set notation on each end, and this is called a relation. So a relation is just a set of ordered pairs, okay? Now our job is to maybe either look at this table of values or look at this set of ordered pairs or this relation and talk about whether it's a function or not in those forms. Now, all you have to look for is to see if you have a repeating x value, if you will, or x coordinate with a different y. If you have that situation where the x repeats and the y is different, it's not a function. So a lot of times with functions, you're looking for failures. So a function can't have a repeating x with a different y. Okay? That's what you're looking for at the function. We'll look at some examples in a second, but looking at this one, do any of these values repeat? Okay? Well, that's your first indication, and so you don't have to worry about that. And then if they did repeat, you'd see if they have a different y. If that happened, it's no good. So this one is, yes, it is a function, for what you can tell. Okay? So let's look at some other situations here. Just some scenarios. We don't know what this data is or these x and y combinations are. And let's just answer yes or no if they're a function. So looking at these x values, none of them repeat. So the y's really don't matter. So best we can tell, yes, this is a function. Let's look at this one. The x's, -2, -3, 6, -2. So we're looking at these right here. If they have different y's, it's no good. So this one is a no, it failed, okay? Now, let's look at these relations down here, this set of ordered pairs. We got 1, 2, 3, and 4 in the x. So we don't have any repeats, so I think we're okay. That's a function. Let's look at this one. We have a 1, a -1, a 2, and a -2. None of those repeat. Now, the y's repeat, but that's okay. So this one is yes. That is a function. Now remember, you're looking for repeating x's with different y's. Let's move on. Now over here, the x's and y's are sort of demonstrated with mapping. If you didn't like this mapping, you could come over here and write these as ordered pairs if you wanted, Negative 2, 1 would be the first one. These are little tiny, 1, 2. You could write those as ordered pairs, look at them that way, or you could set up a table of values. But looking at this, there's an x going to this, but this x, a 4.5, goes to a 4 and it goes to a 5. So if you're writing down ordered pairs, you'd write down 4.5 with a y value of 4, and then it would repeat itself, 4.5, and go to a 5, and that's no good. So this mapping problem is a no. Okay? So there's different ways we can look at functions, all kinds of ways. Relations, table values, mapping, and we'll see graphing here in a second. But let's talk about example 2, a function rule. So notice this might look familiar to you. This is just an equation, y equals 2x plus 4. We've looked at those equations. That's in a great form. So a function rule is just an equation that represents a function. So I'm going to abbreviate here, I hope. So that reps a function. Squeeze that in there if you can. Okay? Now, can you evaluate these? Well, of course you can. You've been doing that. So let's evaluate, which means substitute and simplify final order operations. Again, you probably want to put those in parentheses. So you would take that x equal to 3 and put it right there. So instead of 2 times x, you have 2 times 3, which is 6, that's right, plus 4 is 10. So we got a y value equal to 10. So we can evaluate function rules, if you will, or their equations. Now, if we're talking about domain and range, those are other words that are slung around. Your domain is just nothing but your x values, and your range is your y. Okay? Sometimes they call those inputs and outputs. So let's organize our thoughts here in just a table here. So things that you've seen in math and science and so forth, let's organize. We're sort of talking all the same stuff. So we know about x's and y's and ordered pairs there, if you will. You know about domain and range. You know about something and output. What goes here? That's right, that would be input and output. And then from science class, you see this a lot. You have something called a DV. That's your dependent variable. And some of y'all have your IV. So that sort of puts everything in perspective and organized. So those things can be interchanged, if you will, and talked about. But let's finish up the lesson. I mentioned that we'd be working with some graphing stuff. So let me clear this out of the way for you guys. So here are a couple graphs. Here's 3 of them. All these different shapes. You've graphed some of these already this year. You see this graph right here? That's a line. Well, you could write down infinite number of points and put those in a set. You could do a table of values on those things. But there's a simpler way to go ahead and talk about whether this is a function. All you have to do is do something called the vertical line test. So you could take your pen or pencil and just move that across the graph. Okay? So each time you move this vertical line or this pencil across there, if it just hits the graph, meaning this line, one time, it passes. It is a function. So if you see a line like this, and you move a pencil across it or your finger, whatever you have, and this vertical line only hits it one time as you move it across. There's once there, there's once there, once there. As you move it across, it passes. Remember, we're looking for failure, so yes, that's a function. So let's look at a shape that's not a function. So if we move this across, like right there, right where those 2 points are, a vertical line hits this graph twice. And what that indicates is that you have an x value with 2 different y's, and that's no good. But the vertical line test can tell you that real quick. So this would be a no. If we moved it across this U-shaped graph, if you will, a quadratic, sometimes it's a little hard to tell, but this line slowly moves off to the right there. But that passes, so that's yes. So if you're given a graph, the easiest thing to do is use the vertical line test. So use the vertical line test to determine if a graph is a function. So, we've talked about what a function is, how it's, how it can be depicted, a graph, a table of values, relation, which are ordered pairs. We know that they come from function rules or equations, if you will. You already knew that. We know about inputs, outputs, domain, range, x's and y's. Again, domain is your set of all input values. Range is your output values. Because we're going to see here coming up, you might have more than one input and more than one output. So, thanks for watching.